When we come to our chapter solutions, what is the definition of the solution? Solution, a mixture of two or more components to form a homogeneous one. The definition of the solution is a homogeneous mixture of two or more than two components is known as solution. When we talk about the solutions are doesn't mean that they are always present in liquid state. Solutions may be present in solid state. Solutions may be present in gaseous state also. So, in any solution, two or more components put together physically and forms a homogeneous mixture. In that homogeneous mixture, several components may be present. If you talk about the binary solutions, in a binary solution, only two components are present. One component is present in lesser quantity, another component is present in larger quantity. So, when we talk about solution, our binary solution is composed of solute and solvent. What is meant by solute? Solute. It was taken from Latin word solutus. Solutus. It means it is distributed in the other substance. Solutus. It was taken from Latin word which means dissolve. Which means dissolve. This solute is present in smaller quantity. Solute is present in less quantity in the solution. When we talk about solvent, the solvent is taken from Greek word, it means solvo. Solvo means free up or mix. The component which is present in larger quantity in the solution is called solvent. For example, take a beaker, say this is water, add a few crystals of sodium chloride. Here, water is present in larger quantity, so that it is a solvent, whereas NaCl is going to dissolve in it, so that it is a solute. Remember that the physical state of the solution NaCl in water is in liquid state. The physical state of the solution is determined by solvent only. That's why here H2O is a solvent and NaCl is solute. Students, let us take one more example to explain solution. Everybody knows about gold. Take 24 karat gold. It is pure one. Say it is solvent. To this, impurity like copper is added. This is in limited quantity, it is solute. It gives 22 karat gold. Now, this 22 karat gold is a solution. It is a solid solution. It consists of gold particles as well as copper particles. So, two components are present in it. 22 karat pure gold is solvent, copper is solute. If you observe the physical state of both the gold, that is pure gold and ornamental gold, they are in same each other. So, the solvent of the solution will decide the physical state of the solution. So, let us discuss about the types of solutions. Types of solutions. Based on the physical nature of the solvent, solutions can be divided into three types: gaseous solutions, liquid solutions, and solid solutions. Based on the nature of solvent, solutions are, for example, aqueous solutions. Aqueous solutions means what? Water is the solvent. Solvent is water. Ammonical solution. Ammonical solution. Here, liquid ammonia is the solvent. Alcoholic solution. Here, alcohol is the solvent. So, based on the nature of solvents, there are three types: aqueous solution, ammonical solution, alcoholic solution. If either water or ammonia or alcohol is not taken as solvent, other solvents like carbon tetrachloride, chloroform are taken, they are non-aqueous solutions. Non-aqueous solutions. Let us talk about based on the number of components. Based on the number of components, if two components are present, they are called as binary solutions. Binary solutions. If three components are present in the solution, that solution is said to be ternary solution. Ternary solution. If four components are present, that solution is quaternary solution. But the third type of classification, if you see, that is based on the nature of physical state of the solvent. As I already said that the physical state of the solvent decides the physical state of the solution. So, based on the nature of the physical state of solvent, solutions are of three types: gaseous solutions, where solvent is gas; liquid solutions, where solvent is liquid; and thirdly, gas or solid solutions. Solid solutions, where solvent is solid. Now, what about the solute? The solutes may be solid, may be liquid, may be another gas. So, the solutes, solid, liquid, gas, will dissolve in gas, then we'll get three types of different gaseous solutions. For example, here nitrogen is there. If camphor, this is camphor. Camphor is a solid, nitrogen is a gas. These two forms a homogeneous gaseous solution. Here, solid in gas solution. If we take a vessel, here nitrogen is present. Now, few drops of chloroform. So, chloroform in nitrogen is an example of liquid in gas. This is another vessel. It is filled with nitrogen. Nitrogen is a solvent here. Now, oxygen is introduced into it. Oxygen in nitrogen is an example of a gaseous in gas solution. So, air is an example of this category. So, from gaseous solutions, we will observe three scenarios: solid in gas, liquid in gas, gas in gas. These three types of solutions comes under gaseous solutions. When we talk about liquid solutions, in all these solutions, solvent is a liquid. Now, what about solutes? Solutes may be solids or liquids or gases. Again, three scenarios we can observe here. Take a beaker, fill with water, this is solvent, and add some glucose. So, glucose in water is an example of solid in liquid solution. Take water, add ethanol. Now, this homogeneous mixture, ethanol in water is formed. This is an example for liquid in liquid type of solution. Take another beaker, fill with water. Now, pass oxygen gas into it. Oxygen passed into water, it dissolves and forms a homogeneous mixture. So, it is a gas in liquid type of solution. Now, let us talk about solid solutions. Solid solutions. Here, solvent is a solid. Solvent is solid. What about these solutes? Another solid may involve in solid. Solute may be liquid. Solute may be gas. Now, again three types of solid solutions we have. If you take brass, brass is a mixture of zinc and copper. Zinc is a solid and copper is a solid. So, this is solid in solid type of solution. Take sodium metal, add few drops of mercury. Then amalgam of mercury and sodium solution is formed. So, sodium amalgam is an example of liquid in solid type of solution. And take palladium. Palladium is a metal which is a solid, and into this pass hydrogen gas. Then hydrogen gas will occupy the interstitial space of palladium, then hydrogen in palladium metal gives the gas in solid type of solution. In this way, the solutions may be in gaseous state, may be in liquid state, may be in solid state. It doesn't mean that solutions is always in liquid state, that is not correct. So, from these three kinds of solutions, we will have 9 types, 3 into 3, 9 types of solutions we have. So, these 9 types of solutions, regarding on this, we can frame some questions also. For example, sodium amalgam is an example of which type of solution? Sodium amalgam is a mixture of mercury and sodium. Sodium is in larger amounts, so it is solvent. Mercury is the little amount, that is solute. So, sodium amalgam is a liquid in solid type of solution. So, let us explain all the 9 kinds of solutions put together. 3 types of solutions gives 9 types of possibilities of different solutions. So, there are altogether 9 types of solutions are present. Solid in gas. Solid in gases type of solution example is camphor in nitrogen gas. Camphor is solid, nitrogen is the gas. Liquid in gas example is chloroform in nitrogen gas. The example for gas in gas is air. Air is a mixture of oxygen and nitrogen. When we come to solid in liquid type of solution, solid in liquid, sugar solution in water is an example of solid in liquid. What is the example for liquid in liquid? As everybody knows, like alcohol in water, both mix vigorously to form homogeneous solution. Gas in liquid, oxygen gas dissolved in water is an example of gas in liquid type of solution. Then come to the solid solutions. Solid in solid, ornamental gold is an example, or brass. Brass is an example of solid in solid. Liquid in solid, amalgam of mercury in sodium metal. Whereas gas in solid type of solution example is hydrogen gas in palladium metal. When a gas is occluded in a metal, it is known as occlusion. Occlusions are examples for gas in solid type of solutions. Expressing concentration of solutions. The composition of solution is explained by expressing its concentration. So, if you know the concentration, then it is very easy to explain the composition of the components present in that solution. There are 2 ways for expressing the concentration. One way is qualitative method of expression. It's just like a comparison. Suppose you take a beaker, this is a solvent, few drops of solute is added. This is sample A. Take another beaker. Now, here more solute. See the dots here, here more, less, here less. This is sample B. Here it is a solute. In this qualitative method, we can relatively say that solution A is less concentrated than solution B. Why? Here the amount of solute particles is less, so less concentrated. Here amount of solute particles is more, so it is more concentrated. So solution A is less concentrated than solution B. So this qualitative method creates a little bit confusion for the students. So qualitative method is not properly used. It is not used nowadays. So the best way of expressing concentration is quantitative method of expressions. Quantitatively, there are so many methods to express the concentration in the quantitative manner. Those are mass percentage, otherwise W by W, volume percentage, mass by volume percentage, parts per million, simply we can say ppm. Mole fraction denoted with X. Molarity denoted with M. Molality denoted with small m, and normality is capital N. So all these are various methods to express quantitatively. So let us see one by one of these. It is denoted with W by W. What do you mean by mass percentage? The amount of the solute present in 100 grams of the solution. The amount of the solute present in 100 grams of solvent, not solvent, 100 grams of solution is called mass percentage. Mass percentage is equal to the amount of the component by total mass of solution into 100. This expression is used to calculate the mass percentage. For example, take 10 grams of glucose, dissolved it in 90 grams of solvent water. Then solution is formed whose weight is 100 grams. 10 grams mixed with 90 grams, total mass of the solution is 100 grams. Therefore, weight by weight percentage of glucose component is equal to its mass by total mass of the solution. You should not write 90. Total mass of the solution is 100 grams into 100. So 10%. So here, if 10 grams of glucose is dissolved in 90 grams of water to give 100 grams of solution, so 10% glucose by mass means 10% glucose by mass means 10 grams dissolved in 100 grams of the solution. This mass percentage is generally used to express concentrations in the industrial purpose, industrial estimations. Mass percentage is widely used in the industrial estimations. Generally, in the market, commercial bleach is available 3.62% mass percentage. 3.62% mass percentage means 3.62 grams of sodium hypochlorite present in 100 grams of solution. 3.62 grams of sodium chloride present in 100 grams of aqueous solution. So, that is known as commercial bleach. In the market, commercial bleach is available in the 3.62% by mass. So, in the entrance examination, they will touch this question exclusively for NEET. What is the mass percentage of commercial bleach? Answer is 3.62 mass by mass percentage. The volume of solute present in 100 ml of the solution is known as volume percentage. How it is calculated? Volume percentage is equal to number of milliliters of a component by total volume of solution into 100. ఘనపరిమాణ శాతము ఎలా నిర్ణయిస్తాము? ఒక అణుఘటకము యొక్క ఘనపరిమాణము మిల్లీలీటర్లో బై ద్రావణంలోని మొత్తం అణుఘటకాల ఘనపరిమాణం ఇంటూ 100. ఇలా వేస్తే మనకి ఘనపరిమాణ శాతం అనేది వస్తుంది. Let us take one example. 10 ml of ethyl alcohol is mixed in 90 ml of water. You will get alcoholic aqueous solution of 100 ml. This is the volume of the solution. This is the volume of the ethyl alcohol component. So, volume percentage is equal to 10 by 100 into 100. So, 10% volume by volume ethyl alcohol aqueous solution means 10 ml of ethyl alcohol present in 100 ml of water. In daily life, in cold countries, ethylene glycol is used to reduce the freezing point of the water present in the radiators. On that bottle, they will write 35% volume by volume ethylene glycol, which is used as antifreeze. 35% volume by volume ethylene glycol means 35 ml of glycol present in 65 ml of water. Total volume of the solution is 100 ml. So 35% weight by weight ethylene glycol means 35 ml present in 100 ml of the solution. It is used to what? It is used as antifreeze. The antifreeze reduces the freezing point from 0 degrees centigrade to minus 17.6 degrees centigrade in the radiators. So, even in cold countries, even minus degrees approach, the water in the radiators will not solidify. That is the rule of use of antifreeze. Let us talk about the next concentration method, that is mass by volume percentage. The amount of solute present in 100 ml of the solution is called mass by volume percentage. 100 మిల్లీలీటర్ల ద్రావణములో కరిగి ఉన్న ద్రావితపు భారాన్ని భార ఘనపరిమాణ శాతం అని అంటారు. W by V percentage is calculated as the mass of the component by total volume of solution into 100. This expression is used to calculate the mass by volume percentage. Generally, this method is used to express the concentration in pharmaceutical industry and chemical industries. For those two industries, mass volume percentage is appropriate to express concentration. Let us discuss parts per million, ppm. When this parts per million term is used, if the amount of the solute is in trace quantities, then we will express the concentration in terms of ppm. Solute must be in trace amounts. So, parts per million is nothing but number of parts of the component by total number of parts of components in solution into 10 power 6. This expression is used to calculate the ppm. For example, sea water. Sea water contains so many salts that salts are present about 6 into 10 power minus 3 grams of salts are present in the 1 liter of sea water. 1 liter of sea water present in 6 into 10 power minus 3 grams of salts. What is this concentration of salts? We know volume of sea water is 1 liter. Therefore, weight of 1 liter of sea water is approximately 1000 grams. Weight of salts in that is 6 into 10 power minus 3 grams. Here grams, here also grams. Parts are expressed in grams here. So, in 1000 grams of sea water, 6 into 10 power minus 3 grams of salts are present. Therefore, the concentration of salts in the sea water is 6 into 10 power minus 3 is the parts of sea salts. 10 power 3 is the total number of parts in the solution into 10 power 6. That means 6 ppm is the concentration of the salts in the sea water. Sometimes ppm is also expressed in micrograms per liter per milliliter. ppm nothing but micrograms per milliliter. It is nothing but the ratio of number of moles of one component to the total moles of the components present in the solution. For example, if you take a solvent, it contains binary solution. These are the solutes, solvent molecules, component A, and this is component B. The black dots are component A and the white circles are component B. This is the solution of a binary mixture. In this, which type of particles you are able to see more? The white circles. That means the fraction of B is more in the solution when compared with the fraction of A. Therefore, mole fraction of A is equal to number of moles of A by total number of moles present in the solution. Mole fraction of A is equal to its moles by total number of moles. Similarly, we can calculate mole fraction of B. Number of moles of B by total number of moles of all components in the solution. In binary solution, the sum of the mole fractions is always equal to 1. How it is equal to 1? For instance, XA you can write NA by NA plus NB. For XP we can write NB by NA plus NB. In both the terms, denominator is common. So, in the denominator NA plus NB, here NA plus NB cancelled equal to 1. If the solution comprises of A, B, C, D, so on up to Z components, here also mole fraction of A plus mole fraction of B plus mole fraction of C plus so on mole fraction of Z should be equal to 1. So, in binary solution, sum of the mole fractions is taken as unity. In more than 2 components are present for such type of solutions also, the sum of the mole fractions of all components should be taken as 1. In binary solution, if you know the mole fraction of solute, by subtracting it from 1, you will get the mole fraction of solvent. So, if you know the mole fraction of solute, you will get the mole fraction of solvent, because the sum of these two is equal to 1. For example, if we calculate the mole fraction of 10% weight by weight NaOH solution. This is my question. 10% weight by weight. How it is solved? Weight of NaOH is 10 grams. Number of moles of NaOH 10. What is the molecular weight of NaOH? 40. 1 by 4. Weight of solution is equal to 100. Weight of solvent water is equal to 100 minus weight of solute 90. Therefore, number of moles of water is equal to 90 by its molecular weight. Now, mole fraction of NaOH is equal to number of moles of NaOH by number of moles of NaOH plus number of moles of water. Now, what is the number of moles of NaOH? 1 by 4 by number of moles of NaOH plus number of moles of water is 90 by 80 means 5. You will get 0.25 by 0.25 by 5.25. This is equal to 0.0 approximately 5. This is the mole fraction of NaOH in the solution. If you subtract this value from 1, you will get the mole fraction of water in the solution. In this way, we can solve the numerical questions in mole fraction. The number of moles of solute dissolved in 1 liter of the solution is called molarity. So, molarity is nothing but number of moles in V liters of the solution. We know number of moles is equals to weight of the solute by gram molar weight into 1 by volume in liters, nothing but molarity is equal to weight by gram molar weight into 1000 by volume in milliliters. This formula is used to calculate the molarity. Units of molarity is moles per liter. Moles per liter. This molarity, the concentration term is present in the denominator. As temperature increases, the volume of the solution may also increase. As volume increases, the number of moles per unit volume decreases. So, temperature increases, molarity decreases. So, molarity is temperature dependent. Now, let us see another term, that is molality, denoted with small m. What is the definition of molality? The number of moles of solute present in 1 kg of the solvent. What is molality? The number of moles of solute present in 1 kg of the solvent is known as molality. Molality is calculated as weight of the solute by gram molecular weight into 1000 by weight of solvent in grams. This expression is used to calculate the molality. Units of molality is moles per kilogram. Moles per kilogram. Here the amount of solute is in grams and solvent weight is measured in grams. So, both are in grams. So, there is no volume term. So, molality is independent of temperature. Molality is independent of temperature. Independent of temperature, why? There is no volume term in it. That's why molality is the best way of expressing concentration than molarity. Why molarity is the best way of expressing concentration? Because the molality is expressed in terms of mass but not volume. One more thing, it is temperature independent. That's why the molality is more advantageous method to express the concentration of the liquids. So, we have seen the various types of methods of expressing concentrations in this part. So, based on these methods, based on these formulae, you will be having so many numerical problems. They are very important for coming JEE mains and NEET examinations. So, let us have a look on various types of objective questions on this concentration methods. Let me take this objective question. More concentrated solution among the following. Option 1, 1 molar NaOH solution. Option 2, 1 molar NaOH solution. 3, 1% weight by mass, mass by volume NaOH. 1% weight by weight NaOH. Among them, we have to find out the more concentrated solution. For this, what do you mean by 1 molar NaOH? 1 mole of solute in 1 liter of solution. 1 mole weight is how much? Molecular weight of NaOH is 40. So, 40 grams dissolved in 1 liter solution. This is regarding option 1. What is 1 molar NaOH? 40 grams means 1 mole. 40 grams is dissolved in 1000 grams of solvent. See, in 1 liter of solution, suppose density of the solution is 1 gram per cc, 1 liter of solution is equal to 1000 grams of solution. In that, solvent portion is less than 1000. Here solvent portion is more. Solute portion is same. Solvent portion is less in the first case. Solvent portion is more in the second case. So, first one is more concentrated among the two options. Let us think about 1% mass by volume NaOH means 1 gram of NaOH present in 100 grams of solution. If you compare with molarity, in 1000 grams of solution, 10 grams of NaOH is present. Here in 1000 grams, almost 1 liter is 1000 grams. 1000 grams of solution, 40 grams. Here 1000 grams of solution contains 10 grams of NaOH, little bit lesser amount, less concentrated. Similarly, fourth one, if you take 1% weight by weight, so 1 gram of NaOH present in 100 grams of solution. It is also nearly 10 grams is present in 100 grams of solution. These two are lesser. Among these two, here amount is more. So, more concentrated solution among them is 1 m NaOH. 3.65 grams of HCl is present in 16.2 grams of water. This is the weight of what? Weight of solute. 16.2 grams of water, this is the weight of solvent. Then mole fraction of HCl in the solution we have to find out. So, this question is based on mole fraction. First, find out the number of moles of HCl in it. Number of moles of HCl is, weight of the HCl is 3.65, molecular weight is 36.5, 1 mole. Number of moles of water in the solution, its weight is 16.2 and its molecular weight is 18. number of moles of water is equals to almost 8.1 by 9. Therefore, mole fraction of HCl is equal to number of moles of HCl by number of moles of HCl plus number of moles of H2O, that is equal to, say this is 0.1. So, 0.1 by 0.1 plus 8.1 by 9, 0.1 by 1. So, mole fraction of HCl in the given sample is 0.1. So, third option is correct. Let us take this example. Equal volumes of 1m KNO3 and 1m AgNO3 are mixed. Two solutions are mixed here. The concentration of K plus ions in the solution mixture is, here this solution contributes K plus ions only, but not this solution. If concentration of NO3 minus is asked, then the contribution of NO3 minus ions from this solution and from this solution is considered. But here no need for considering the K plus ion, because K plus ion is coming out from KNO3 only. So, in this mixture of solution, molarity of K plus ions is M1 V1 plus M2 V2 by V1 plus V2. K plus 1 molar K plus KNO3 gives 1 mole of K plus ions. Equal volume means, say I have taken 1 liter of each. So, M1 1, V1 1. So, K plus ions are not contributed from AgNO3. So, in the place of M2 0 into 1 liter by 1 plus 1 liter, you will get 1 by 2, that is 0.5 m. So, concentration of K plus ions in the mixture is 0.5 m. That is correct answer is fourth option. 6% say weight by weight was given. Urea is the solute and the remaining is the water, that is solvent. So, question is molality of 6% weight by weight percent urea solution. What is the formula used to calculate the molality? Molality is equal to weight of the solute by gram molecular weight into 1000 by weight of solvent in grams. This formula is used. By using this formula, you can solve the molality. 6% weight by weight means what? Mass percentage here given. 6 grams of urea, 6 grams of urea is present in 100 grams of solution. Most of the students will confuse here. They will treat 6 grams of urea present in 100 grams of solvent. If you consider the solvent as 100 grams, your answer will be wrong. So, 6% mass percentage is given means 6 grams of urea is present in 100 grams of solution. Therefore, weight of solvent is equal to weight of solution is how much? 100 grams, and weight of solute is how much? 6. So, 94 grams is the weight of solvent. This should be substituted here. So molality is equal to 6 by gram molecular weight of urea. You know, urea formula is like this. Its molecular weight is 60. So 60, 6 by 60 into 1000 by weight of solvent 94 grams, 10s are, so 100 by 94, this gives 1.06. So answer is third option. The molality of 6% weight by weight urea is 1.06 m. Initial molarity M1, initial volume is V1, that is equal to M2 V2. M1 V1 is equal to M2 V2. This formula I have to use. Here, initial molarity is 1 molar. Initial volume of H2S4 is how much? 250 ml. That is equals to final volume of the solution should be 0.25. This is a final concentration. We have to find out the final volume here. So final volume V2 is equal to 250 by 0.25. Volume of water to be added is final volume minus initial volume. Final volume is how much? This will be equals to 1000. Therefore, volume of water that is extra to be added, 1000 minus initial volume 250. So that gives 750 ml. That means, say, fourth option is 750 ml. So answer would be 750 ml water to be added extra. The fourth option is then correct.